Okay, so this is actually case study 4, and it begs the question, how are we going to settle in space on the moon and beyond? So we should start out with a little bit of motivation of why do we want to settle or explore the moon, Mars, and beyond. So the moon will provide scientists with new views of early Earth, how the Earth-Moon system and the solar system formed and evolved, and the role of asteroid impacts in influencing Earth's history and possibly future. The moon presents numerous exciting, okay, so here's a picture of like an artist's concept about moon formation. Now, another motivation is that the moon presents numerous exciting engineering challenges. It is an excellent place to test technologies, flight capabilities, life support systems, and exploration techniques to reduce the risks and increase the productivity of future missions. Another thing that motivates us is that our journey will provide us with the first experience of living and working on another world, allowing us to test advanced materials and equipment in temperature and radiation extremes of space. We'll also learn how to best employ robots to support human tasks, explore remote locations, and gather information in potentially hazardous regions. By successfully establishing a presence on the moon, we will enhance life on Earth and prepare to explore the rest of our solar system and beyond. Keeping astronauts healthy in a lower gravity and higher radiation environment than Earth is an important challenge for medical researchers. And that's shown up here. The potential benefits to all humans are tremendous in terms of preventing and treating bone and muscle loss in some cancers. Other advances in medicine may follow. And then finally, exploration of the moon also creates new business opportunities for technological innovations and applications and utilization of new resources. Establishing outposts on the moon enables adventurers and explorers to extend exploration and settlement to planets and moons beyond Earth. There is an entire universe of unknowns waiting for us to investigate. So what is our previous experience as humankind in exploring the moon and beyond? Well, here are two pictures that show some previous Apollo missions. Here, we've got an astronaut getting off of a dune buggy at the rim of a crater. Here we have the view from the far side of the moon from Apollo 13. So the farthest we have sent humans to the moon was during the Apollo missions. In April 1970, the crew of NASA's Apollo 13 mission swung around the far side of the moon at an altitude of 158 miles or 254 kilometers, putting them at 400,000 kilometers away from Earth. It's the farthest our species has ever been from our home planet. So here's a collage of sci-fi movies that we've actually talked about a lot of them already. We've been dreaming and thinking about human struggles in space exploration for a long time, visible through our constant interest in sci-fi movies. This is just a smattering of recent popular sci-fi movies, specifically telling stories about humans in orbit or on other planetary surfaces. I think we've actually seen a rise of interest in space exploration as a whole, and that's representative in the more frequent release of space movies, books, and TV shows. It's actually pretty interesting to see space glamorized from the public's eyes. For example, do you guys remember in The Martian when a NASA representative got up on a podium and behind them was like a really nice, swanky NASA Center press room? Like, I just think it's so hilarious that people think NASA's so well off, but really the buildings are like pretty run down. Okay, anyway, so those are our ambitious dreams, but how about actual upcoming interplanetary missions? Future actual missions include the NASA Artemis mission, which some of you may recognize this graphic for. NASA's Artemis program aims to land the first woman and next man on the moon by 2024. With Artemis missions, NASA will land the first woman and first person of color on the moon, using innovative technologies to explore more of the lunar surface than ever before. We will collaborate with commercial and international partners and establish the first long-term presence on the moon. Then we will use what we learn on and around the moon to take the next giant leap, sending the first astronauts to Mars. We will build an Artemis base camp on the surface and a gateway in lunar orbit. These elements will allow our robots and astronauts to explore more and conduct more science than ever before. Neat. Here are other future aspirational missions. So the previous one actually has a budget. These do not have a budget. They are just concepts as of right now. On the left is SpaceX's under development rocket, or sorry, their concept of going to Mars. SpaceX's underdeveloped rocket has yet to complete its first orbital flight, but in a Monday interview, the SpaceX CEO appeared positive that the ship will meet its most ambitious targets on time. These include a trip around the moon in 2023 and getting to Mars this decade. So we'll see. Elon has a tendency to overpromise. On the right is the International Lunar Research Station. It is a planned lunar base currently being developed by Roscosmos and the China National Space Administration. This lunar base will serve as a comprehensive scientific experiment base built on the lunar surface or in lunar orbit that can carry out multidisciplinary and multi-objective scientific research activities, including exploration and utilization, lunar-based observation, basic scientific experiment and technical verification, and long-term autonomous operation. Statements from Roscosmos and the Chinese Space Agency underline that the project will be, quote, open to all interested countries and international partners, end quote. It will be developed through a number of upcoming robotic Tong'e missions across the 2020s and expanded through the 2030s. Okay, so there are some main topics of concern in settling on the moon. Sorry about the siren. Okay, anyway, so colonization or habitation of the moon as a material process has been taking place since the first artificial objects reached the moon after 1959. For example, lunar landers scattered pennants of the Soviet Union on the moon, and US flags were symbolically planted at their landing sites by the Apollo astronauts. But technically, no nation claims ownership of any part of the moon's surface. So that touches on the first point of access. Russia, China, India, and the US are party to the 1967 Outer Space Treaty, which you all have read, which defines the moon and all outer space as the province of all mankind, restricting the use of the moon to peaceful purposes and explicitly banning military installations and weapons of mass destruction from the moon. The landing of US astronauts was seen as a precedent for the superiority of the free market socio-economic model of the US, and in this case, as a successful model for spaceflight exploration and ultimately human presence in the form of colonization. In the 1970s, the word and goal of colonization was discouraged by NASA, and funds as well as focus shifted away from the moon and particularly to Mars. But the US eventually nevertheless opposed the 1979 Moon Agreement, which aimed to restrict the exploitation of the moon and its resources. So that's that point up there about the USA did not sign the 1979 Moon Agreement, but 18 other nations ratified in 2020. And my speculation there is that in the 1979 Moon Agreement, there was specific mention about not exploiting the moon's resources, but the main space agencies didn't sign, likely because they wanted that option in the future. They were the closest to getting it. That's my belief. Subsequently, the treaty has right. The last couple of points I wanted to make, that last point, we already talked about rights of nature, so I don't need to review it, but the rights of nature concept challenges 20th century laws as generally grounded in a flawed frame of nature as a resource to be owned, used, and degraded. Proponents argue that laws grounded in rights of nature direct humanity to act appropriately and in a way consistent with modern system-based science, which demonstrates that humans and the natural world are fundamentally interconnected. Like our last conversation, there is conversation of imperialism and colonialism, the imparting of our beliefs, our culture into the birth of a new state potentially. And that kind of ties into our perspectives on markets and socioeconomic models. We were talking about free markets versus a communist worldview. So those are all tied up into concerns in settling on the moon. Okay, so to review, this is the Outer Space Treaty of 1967. In the back, you'll see the countries that have ratified these articles. They include the major space powers across the world. So the US, a lot of Europe, Russia, Japan, Canada, and then India and China were budding. They weren't really a major player in 1967, but since then, are major players. So the articles go through rights for the benefit of all mankind, no national appropriation, maintaining international peace, anti-weapons, regarding all astronauts as envoys of mankind. So this one we haven't really talked about before. If there is a person in need of rescue, then regardless of the country or that the space agency comes from, they are obligated to extend assistance. Another article in here that all states shall bear responsibility for any national activities in outer space, whether it's government or non-government. That each state party is liable to damage to another state party. That the state parties are motivated by the principle of cooperation and mutual assistance. So it's all in good faith. State parties are afforded an opportunity to observe objects launched by those states. State parties agree to inform the Secretary General of the UN. That spacecraft or other facilities in space shall be open to other parties on a basis of reciprocity. So it's kind of like country A uses country B's base, and country B is like, hey, could we also use like maybe your rover sometime? Yeah, this treaty was open to all states for signature and was also open to other amendments. In the 50 years that it's been up, yeah, all of these countries in the background have signed. The red ones have not. Yellow ones pending. Okay, and another thing that you read this last week are the Artemis Accords, which is the updated version of the Outer Space Treaty. It's quite a bit longer. Like I said before, there are some redundancies that I'm not going to go over that are abbreviated here next to the different sections that are redundant. It's just a little confusing that I assumed we went over this in case 5, but I'm sorry. To go back, what's new in the Artemis Accords that wasn't in the Outer Space Treaty is the release of scientific data. So in this updated Accord, the signatories retain the right to communicate and release information to the public regarding their own activities. Signatories are committed to open sharing of scientific data. That's great, love it. And the commitment to openly sharing scientific data is not intended to apply to private sector operations. So there's a little bit of proprietary protection. What else is new is that since 1967, there are objects in space that have heritage. So in this 2020 accord, the signatories intend to preserve outer space heritage. And what else is new is the Moon Treaty talked about space resources, but that one was largely rejected because space resources were off limits. This new piece of legislation says that space resources are critical, can be extracted, with the addendum that signatories need to inform the Secretary General of the UN of their activities. What was also new about this accord was the explicit mention of orbital debris. So the two parts to this are that the signatories commit to plan for the mitigation of orbital debris as part of their mission planning process. This harkens back to our first case study when we were talking about space debris and what are people doing nowadays to mitigate space debris. The signatories commit to limit, to the extent practicable, the generation of new, long-lived, harmful debris. Okay, cool. So now we are going to start our discussion. Here's the prompt. Humans have traveled to the moon more than half a century ago, are going to return to it in larger numbers soon, most probably through the creation of permanent habitats. Plans for human exploration of Mars are actively pursued. So have we learned enough about ourselves and our history to avoid the mistakes that we've made on Earth, which include such things as over-commercialization, space pollution, and proliferation of military technology? All right, stop the recording.